Friday in class, we'll be taking the Unit 9 test.
Yeah.
Now, some of you already talked to me. If your family's headed out on spring break early and you won't be here, then you just need to take the test on your own. And you need to take it before the start of spring break. So it's closing on Saturday, and I don't want to have to reopen it if you're not going to be here. Okay? One thing, if you're here, you don't have to worry about it, but if you're not, make sure you take it. It's actually going to open tomorrow online, because someone in B6 is headed out on Thursday, so they got to take it tomorrow before they leave on vacation. Okay? Homework tonight is to finish up the worksheet practice problems 2. You should have done the front side already, but you'll now know how to do all of the back side. And then, because we haven't had like individual topic quizzes for this unit, because it's kind of been so consolidated, I just made one Unit 9 quiz as a review.
Okay, that makes so much sense. I keep checking AP class, I'm like, I've got to be missing something. I was so worried the whole time.
No, yeah, it's just because it was so short, I just did it all. So it's like 20 questions, a little bit from every topic, but it should hopefully be a good review for the test on Tuesday. Okay? All right.
It kind of tastes like those cherry lollipops. But also like medicine.
Dang, the perfect Kool-Aid.
Okay, so last time we ended right after we had looked at this chart, and I stopped because I didn't want to run out of time doing a problem. So let's just review really quick what we learned so we can kind of build from there. So last time we were talking about these values known as the E cell value. This value tells us the voltage that is released as this process happens as it is written. So all of these right now are written as reductions, because notice the electrons are all on the left side of the arrow. Reduction means to gain electrons. When a reaction happens, 2 of these react with each other. Well, you can't have 2 things get reduced. One of them gets oxidized. So the way you tell based off the list is the more positive the value, that one is going to stay the direction it is as a reduction. The more negative the value, or the smaller it is, that one will flip and be oxidized in its place. So let's look at a problem where we can see this, okay? Oh, did we fill that in already? Already.
It's already filled in.
Whoa.
Okay.
I get
But what?
Since you've been
Sorry.
gone.
I blame Gavin.
It's
That was Gavin's fault.
That was my bad.
Okay, so this is already on your paper, but they gave us the voltage for each of these reductions. Okay? The question says determine the half reaction that will occur at the cathode and the anode, and then to calculate the overall cell. So we had a little catchphrase to help us remember what happens at the anode.
Red cat,
There we go.
blue,
Oh.
or just dead ox. What was it?
And ox. It's an ox.
So red cat means reduction is at the cathode, and ox is oxidation is at the
And the
anode.
red cat is a jerk to the ox.
Oh yeah, you had a story. I forgot we had a whole story about
Dr.
this.
Seuss.
So, to identify what's being reduced, we look for the more positive voltage. So in this case, so this would happen at the anode, and this would happen at the cathode. So label that. This is reduction, which means the cadmium is going to be oxidized. So when we calculate part B for the overall cell, you take the reduction as is, but then you flip the one that's being oxidized because the reaction is going the other direction. So I'm going to write it kind of differently, but just so you can see. So we're going to add, and then we're flipping the sign, so that's why it becomes 0.403. Got it.
Why is the cathode oxidized and the anode red?
Because
Ah! I don't know.
that's a news point. Anyone? I would appreciate extra credit.
Thank you.
From
Okay,
Mr.
so
Barker's
red
class.
cat
I was like,
I remember.
and sorry. Thank you for clarifying for those that were just as confused but said nothing.
Forgot how long.
Okay, does that mean I put my numbers were backwards? Did I do my numbers right?
I'm not sure, honestly.
Don't worry about it.
Oh,
I don't even know which one I'm gonna do.
No,
okay,
in the
here's
math
what
class
we
I'm
got.
in now, if you
Wait,
call out
okay,
story
Okay, everyone,
before
freeze.
period,
Rewind. Start
It's
again.
rewind time, everybody.
Okay, so the more positive the value stays as the reduction. So this one is being reduced.
Oh,
Because
what?
this value is more positive. Okay, so the more positive the E value, that one will stay as a reduction. This one would go to oxidation.
So that one becomes more negative, and the one that's positive becomes more positive.
Say that one more time.
No,
Okay.
Yeah.
So reduction is what happens at the cathode. And then this would be the anode.
yes.
And
I didn't have it in anode.
wait. So, is oxidation always the smallest number? Or the
Yes.
most? Okay.
Yes, that's a very good putting out of it. Smaller the number, that one will be oxidized always.
Okay. There's no exception.
Okay? Which I guess that makes sense because the oxygen is smaller than the
Yes,
What are the oxygen?
and personality. The oxygen is different, it's full of cat is genius.
No, the ox is just like, it lets the cat walk all over it, you know?
Yeah,
And
the
fat
oxidation
is
to man.
Okay, so we flip the sign of the thing that's being oxidized because that means the equation is the other direction. And so then we just add them together to get the overall voltage.
Which is,
Somebody's got that.
What would that be?
I think it's gonna be,
2.7.
How did it
No.
be 2.7?
2.69?
263.
I meant 20.
Oh,
Oh, I got it, right, maybe.
Is that right?
No, maybe not.
it wouldn't be
I don't think so. See?
It'd be
We can do that.
267.
267
When nobody has a calculator.
volts.
I definitely have calculator, I'm too lazy to do that.
Okay? Now, the thing about these problems, everybody, is you really only, especially in this one, you're gonna get one of two answers, right? You're either gonna get a positive number, or if you do it backwards, you're going to get a negative number. The key thing, though, is that if the reaction is happening on its own, the voltage has to be positive.
So if you get a negative number,
You
you're
know
like,
you did it backwards. Yeah.
Oh, so it's easy to like.
Unless they tell you, which we'll learn about here in a second, it's an electrolysis reaction because then you're putting energy into it. But,
electrolysis.
yeah, anytime it, like, if we're just gonna mix two things together and we want voltage, it has to be a positive voltage. Okay, let's take a look at another problem and then you can have a smiley face here.
No, they weren't. They were playing the other song. That was
So
like,
weird, yeah.
and then you just
Okay, I'm gonna do part A. Give me your attention here, everybody. And then you'll do part B for a smiley face. Okay? So this says determine whether the reactions are spontaneous under standard conditions. So in this case, it may be negative, because that would mean it's not spontaneous. So we're just taking the equations as written. So the first step is you've got to figure out what is being oxidized and what is being reduced with how the equation is written. So looking at part A here, everybody, I see that copper is going from nothing, so it means it's at 0, because it doesn't have a charge, to a +2 charge.
Oxidized.
No,
So that's being oxidized.
I'm so confused.
Because ox
I
is
keep
losing.
mixing things up.
And then hydrogen is going from a +1
So it's gaining
to
oil.
a 0, so it's being reduced. Questions on how I identify that? Because if you can't identify that, then all your batteries are always going to be mixed up.
Could you just define spontaneous again? I don't, like, what does that mean again?
Spontaneous means it's thermodynamically
Sort
favored,
of happened no matter.
so it's just happening on its own.
Right,
Okay, wait, I got it. I got it.
Okay, so now what we're going to do, everybody, is we know this is being
Oxidation,
reduced.
when you add electrons,
No, ox is losing.
but I thought when you reduce, you take away the
No,
electrons.
reduce,
It's
you
positive.
gain an electron, but it's a negative.
Isn't it when you reduce it, you take away the electrons, so it becomes positive?
No, so reduction means you're gaining electrons, but the
Because-
charge gets reduced, that's why the number goes
Oh,
down.
I mixed up the electron thing, okay.
Yeah.
It feels a little backwards.
I think that was like, it was like reverse psychology.
So
I was just like double
She
reverse.
But if you reverse and reverse, shouldn't you be going the right way?
No, because I was going.
Reverse.
Yeah, reverse psychology.
Taylor.
Okay, so flip your notes, everybody, to the table of reductions. So flip it over, and we need to find the process of hydrogen, H plus going to H2 and find
Isn't
what
it
its
just
voltage
zero?
is.
0.
That's the
Everything
only
else?
one I remember, because I'm just like, hey.
Okay, now find the value for copper.
Alright, here we go. First one to find is awesome. I found it,
You're awesome.
0.34.
Good.
Wow.
Now, we gotta flip it because that's the one being oxidized, so it's gonna be negative 0.34.
So it's not thermodynamically favored.
Good, so we can say this is not favored.
Not.
Would we still have to write the answer or just say not favored? So like the
If-
answer is negative 0.34. But do we have to write that?
It doesn't say.
In this problem, no. If it was like a free response, my guess they would mostly say justify your answer, and that would be your justification, is that word.
Okay, got it.
But, okay, try part B for a smiley face. Ready, set, go. Find the voltage and tell me if it's thermodynamically favored or not.
Wait, are we supposed to remember?
You can. You don't have to, but you can.
We always. Do that again. Okay, one from the reasons.
Give me a pencil drop when you're done.
What? I'm so
We're
sorry.
not.
Okay, hopefully I didn't mix it up this time. Okay, yeah, I think I did that right this time. Another good one, I did that. 2 plus 2 equals
Okay, and then, what are we looking for?
Wait.
It's right here.
Oh. Okay.
No, because don't you flip the sign? See, what am I doing next time?
Oh, yeah.
Wait, but what really matters is that we get favored. Favored is correct, whether or not you know how to add it or subtract.
Okay.
So there we go. What was that?
That was me screaming because my pencil broke.
Oh, did I do my math wrong?
For us, it's hard not
Yours would be a
hard.
little bit different.
For us.
Is that actually
Hey guys, I hate to break to you, but Andy is one of those. And yes, I'll say that on camera. Andy is very good.
I feel like one of the only ones I've ever seen. I'm like
It's so
Okay.
boring.
Bryce, did you get paid?
No, it's okay, actually. I got
Got it?
So is that pH 7 because it's green?
Pretty close to it.
Remember to switch
I'm
to
so good
Okay,
at
give
this.
me a thumbs up if you think it is favored, thumbs down if it's not favored.
Everyone give her a big thumbs up so you get a smiley face.
But yeah.
Unless I'm wrong. If I'm wrong, I'm really sorry.
I got the same answer as you guys.
82%.
No,
Okay,
you
if you're
flipped
saying
the
it's
second
favored,
place,
have a
because
smiley
it's
face.
all-
You should have gotten a positive 0.79 volts.
Because
The other day, someone said a similar thing, but they said
Right
they
here,
got
it's a
No,
positive.
that's 0.82.
That's what I
And
meant.
this
I looked at the wrong
is
part of
also
my notes.
So,
0.82 is
but
what you should have
you
gotten for
flipped the
voltage.
sign.
So-
Yeah.
So,
Okay, let's take a look at another equation.
I'm so excited.
yeah, because you don't flip the sign, you
Yeah,
flip the second.
yeah.
So what we can do now, everybody,
But isn't it from going
is we can relate E,
CL2?
which tells us the value of volts coming out, and convert it into joules of Gibbs free energy. Okay, this equation is on your formula sheet, so you just need to know how to plug things in. Let's define what the variables mean.
Number
N
moles, please stay the same.
corresponds to the moles,
Yeah.
but particularly we're looking at the moles of the electrons.
Oh.
Because that's what's causing the volts, but it is still just moles.
Wait, are there moles of electrons?
Mole is just a grouping of it,
Oh,
right?
yeah,
Six
you're
point
right.
oh two times 10 to the
Okay.
negative.
S
That's
is
a
known
good
as
question.
Faraday's constant. Okay,
I feel like I've heard that before. What's Faraday from?
It's like a hotel or something.
No, the Faraday. It's from a show. I Faraday.
It sounds like the bad guy in a movie.
It
Yeah.
does. No, Faraday.
Fairway?
cage.
Fairway
Maybe
frame?
they were 60.
Are you talking about Faraday cage?
Yeah.
That's the same.
I don't know, man. I'm thinking. It sounds like
Taylor.
something.
I don't
Taylor.
know it, I can't think of it.
Taylor.
I don't know, man.
Is it fairway frame from Parks and Rec?
No. I've
Faraday.
never-
Is that voltage minus moles or times?
No.
Times
I'm not
moles of
talking about
electrons.
that. I don't even know what that
So
is.
what Faraday's constant tells us, everybody,
Electronics from EMP.
is Faraday's value, this value, tells you the energy per mole of electron. So every mole of electron that flows through a wire, this is how much energy is made. So that's what this constant comes to.
Oh.
Wait, is that volts times mole?
Uh-huh. Okay, and then E is what we just calculated, is the E cell value, so how much volts come out there. Yeah,
I can't. What are the
so
labels?
it's joules per volt times moles of electrons.
Okay.
And this value and this equation are on your formula sheet.
Oh,
So you
okay.
don't have to memorize that, we just gotta use that, okay? So let's try a problem here where we use that equation. Oh, first off, there's a typo on this which makes things very confusing, so make sure you cross off this plus sign.
Oh, yes.
Okay, for smiley face, you got 30 seconds to identify what's being oxidized and what's being reduced. Ready, go. Always.
Give
It
me a
just
second.
doesn't have a charge.
What if something's, wait,
Something
if it's not, is it like just being added to H?
So you could have things that are like spectators that don't change in oxidation numbers.
If something is oxidized, does something have to get reduced?
Something has to take the electrons that are being lost, or vice versa.
Wait.
Am I the only one, like, I think it's a little weird. Is that just me?
If he's okay with you coming, you can help make paperclip necklaces.
Can I make those?
No. Well, I just need to know that she's okay with me.
As long as I'm back on the deposit.
Go get enough paper.
Okay.
Dang, laying down the law.
Sorry, I can't harbor hostages, not hostages.
Oh,
Fugitives.
Okay.
Wait a second, first the Kool-Aid.
It's HCl.
Oh, shit, man.
Wait.
How all of them to
Okay, if you said that
Wait,
silver
is that just like a joke?
is being oxidized,
Oh.
you can have
All of a
one.
sudden, Evan's having a heart attack because he thinks that he was drinking HCl.
Oh my god.
And then if you identify that oxygen
Let's go.
is being reduced, you can have a second smiley face. Okay?
Oh.
Now the reason why oxygen is being
Oh, this is
reduced,
like the 2 minus thing where you write it underneath.
Wait, did we get
I was about to
from
ask about
the
that.
last
okay? Okay, so first part of the problem, there's 3 equations we're
Oh,
gonna
I'm
do.
so dumb.
Like I said, first one we're gonna find E
He's
cell.
so mean to me.
Okay.
Terrible thing is I did this in pen.
You do everything.
Why did you
Only
only
because I ran out of life.
So the
Okay, so we're gonna go to our redox table again, just like before. Find the value for silver, which is 1.23. Okay, we're then gonna find the value for oxygen changing into water, which is well, it's 0.18, and then I'm flipping the sign. Would be negative
Wait,
0.80.
0.80?
0.80.
Okay, I thought you said.
Sorry, did I say
0.8.
1?
Yeah.
So that gives us a voltage of 0.43.
Wait, so like, if it's like, what's the difference between something that has a voltage of like a million and something that has a voltage of like 0.0001? Because they're both favored. It's like, will the speed be different, or is it just like they're both favored and therefore they're the same?
One
Good
is like
question.
that.
So it's like, yeah, it's how much electricity it's producing. Think of like a 9-volt battery
Oh, okay, yeah.
versus like, yeah.
You
But that is a good point though, Taylor, in terms of it has nothing to do with speed, right? Like a lower voltage battery doesn't go slower, it just doesn't produce as many electrons, right?
Yes.
Yeah.
Wait, so it's just not as powerful?
Say that again, Evan.
It's just not as like,
Yeah, it just doesn't produce enough power.
okay.
Yeah. Another side note to that that's important to recognize as well, everybody, is that voltage is an intrinsic property. Meaning, someone in B6 asked, which was a good question, is they noticed that there were 4 silvers in the balanced equation. So like, oh, do I times the value for silver by 4? Because when we dealt with enthalpy and heat, we did. But it doesn't apply to voltage actually. You can have more silver, that's just gonna make your battery last longer, but it doesn't increase the voltage of it. Okay? Alright, so now we're gonna do is use that second equation and find delta G. So delta G was negative N Fe.
Fake.
Okay.
What is N?
No, it's good. So you know how like in new the G is silent. So just
Oh, what was agent silent N?
agent
Or
silent G. It's agent silent G. New in the new.
Yeah, that's right.
Okay, so first question is we gotta figure out from the balanced equation how many electrons are being transferred. How many moles of electrons? Any
3.
ideas?
3. Wait.
Count 3
Why?
moving.
Wait,
by
why?
Wait, no, it's
Wait, why 3?
4.
Well, look, it
This
goes
is a 4
1.
AG.
Good.
Oh yeah.
So Evan noticed here, everybody, that we're going from 4 AGs, and they're at 0, to 4 AG pluses.
Dang.
So that means 4 electrons.
Well, if you just look at it, like, it goes plus, so that's 1, and then 2 minus, that's 3. 1 plus 2 is 3, Taylor.
Yeah, it's one of them was negative. And
Oh,
then
you
plus,
did
so
it.
that
Well,
should
yeah,
be
but that's just,
one.
no, that's just moving electron. Okay, no, you're broken.
Okay.
Okay, Faraday's constant, that's our F. Okay,
Friday's from
moles
sorry,
over
my
moles
God.
times moles of electrons.
Wait a second.
And then our E is what we just
Do I actually have to
calculated.
write that into the equation?
I'm so confused.
Like, moles times moles of electrons. I think I'm just gonna write the 9645.
I'm just putting all the units in there so we can track our units, but once you know what the units should be, you definitely put them in there. Okay? Questions on what I plugged in and why?
Where do you get 4?
Yeah, how do you get 4?
So this is how many moles of electrons are transferred in the process. So you really can look at oxygen or silver, because silver is what? Silver's, what do we say, oxidizing? Silver's losing them, and oxygen's gaining them. So I have 4 silver atoms, each going to Ag plus. So they're losing 1 individually, but you have 4 of them. So that means you have 4 moles of electrons.
So 1 electron is a mole.
Yeah, so it's the same idea of like this balanced equation number tells you at the molecular level individually, like per atom, but it's always proportionate to the mole.
It's just a ratio.
Yeah.
Okay.
So if you have 4 silver atoms, you can proportion it to saying that you have 4 moles of silver.
Yeah.
And so that's where the 4 moles of electrons are transferred. Does that help?
Yeah.
Does that help
It's
you?
mean like 4 are going both directions, because they're just.
Yeah, so silver's losing 4, but the 4 that it's losing are the 4 that oxygen is gaining.
Okay.
If you want to look at it from the oxygen side, you can say, okay, oxygen is going from 0 to -2, but in the process there's 2 of these, so it's like you have, right? So total, it's a -4 that's being transferred, which would need 4 electrons. Evan?
This is kind of going backwards, but why did oxygen get reduced and not hydrogen?
Go down and show you guys. Say that one more time.
So why did oxygen get reduced but not hydrogen?
So hydrogen in this case is kind of like a spectator, because if you track its charge or its oxidation number, right here is at a +1,
Mm-hmm.
and in water it's still at +1. So its oxidation number isn't changing, so the electrons aren't flowing through the transfer of hydrogen.
Okay.
Does that make sense?
Yeah.
So a lot of times when you track oxidation numbers, some things won't change in value.
Uh-huh. Okay.
I'll make a mental note to myself that
It's
maybe
kinda like-
after
it was like
break
big-
we'll review oxidation numbers some more.
There was that big chart she showed us, and like oxygen is almost always like -2,
Yes.
and like hydrogen is all like almost always +1.
Yeah, we have those rules for oxidation numbers that we talked about in unit.
I don't even remember.
I think it was unit 4 is where those rules were, but is that
Is there times when there's multiple things being reduced and oxidized?
I can't say for sure, but I would say no, that generally just one thing is being oxidized and then just one thing is being reduced. But I can't think of an example where you'd have multiple, maybe there's one, but yeah, good question.
You
So
should
when
go
I
through
plug
that
this in, I
maybe.
got a real big number.
It's -1659544.2 joules.
I'm gonna round for sig figs.
Uh,
For the fifth,
Yeah, probably something
what
like
would it
that.
be? Units on this answer.
Joules.
Which makes sense for delta G, because delta G is Gibbs free energy. Okay, now does it logically make sense that this is negative and that is positive?
Yeah,
Hi Gavin.
I just
No, it doesn't. Like, what? Where's your logic here?
Hey,
I want to
hey,
hear this. Here
hey.
we go, Gavin. Let's hear it.
Hey, don't bully me.
No, I want to hear it. Come on, let's
Why
go.
are you bullying me right now?
I have faith in him.
I just remembered it was like always backwards from enthalpy or whatever. I don't know.
So what does a positive voltage tell us?
That it's making, it's like energy's going out.
Good, this is how much voltage is being produced. What does a negative delta G mean? It was Max's pun.
I know, so say it, you know him, right?
Do you remember?
I'm trying to
Do you
think.
remember your joke you made?
Oh yeah, it's how much energy it's giving.
Yeah, because this is Gibbs free energy,
Oh,
right?
Oh,
So
God.
this is how much energy it's giving out.
Oh, that makes me so happy. Yeah.
So that's just, it's good mental check to make sure like logically like, oh yeah, that is, otherwise you could easily catch if you made a mistake somewhere, right? If you're like, oh wait, these aren't lining up like they should. So, Evan,
Wait, so when if it's negative and it's Gibbs free energy, would it be like negative because of the electrons or just negative because it's not free? Or am I just,
so the negative here is the direction of energy.
okay.
Right, it's like your bank account analogy where if your bank account is negative, where's the money going?
To the bank. Wait, out.
Out. Right, so negative energy means energy out.
Or
So-
being given
Okay.
away, my friend.
Being given away.
Any other questions on that?
Huh, Taylor?
Give it a rest.
Okay,
Yeah.
last two things and then we'll do our bonus quiz.
How much is
Bonus quiz!
Up to 10 points.
Oh, bonus points?
4 of actual.
Okay,
Extra credit is
now everything we've been talking about so far, we have put that little degree sign.
It means knots.
Good, so we say it E naught is how you talk about
You
it.
sound like a cool boat guy.
That's right.
A cool boat guy.
What is the little degree sign telling us?
Standard conditions.
Standard conditions. For electrochemical cells, standard conditions means you're putting them in a molarity of 1. What we can make though is we can actually make what is known as a concentration cell where we're not under standard conditions and that can increase or decrease the voltage. The whole concept of a concentration cell is the idea that the electrons are going to flow to get to a state of equilibrium, meaning equal concentrations of both cells. Really, when a battery is dead, it's because it's reached equilibrium.
Whoa.
So the
So
electrons
you should
don't
feel
flow.
happy for that.
Yeah, it's
It
finally
finally
reached-
completed its goal.
Yep.
It's finally, you know, happy with
And
itself.
then you
It's,
recharge it and make it suffer again.
oh my gosh, we're like torturing batteries.
I mean, I don't
They're
know if
just
they
like
have
our little
feelings,
slits.
but.
Yes, they do.
Everything has feelings. Have you seen VeggieTales? The cucumber has feelings.
Okay,
And frozen the water has memories.
smiley face question,
That's
don't say
true.
that loud.
Yeah.
Okay, so this is my setup for my concentration cell.
Mhm.
This beaker has this molarity,
Sure.
this beaker has that molarity. Okay,
Whoa.
don't say it out loud, but I want you to see if you can answer the question of why are the electrons flowing from the low molarity to the high molarity? Don't say it out loud, see if you can answer that question. To get to
I got
equilibrium,
it. I
why are
beat
they
you, Taylor.
flowing in
I
that
figured it
direction?
out before you.
Wait, I'm thinking.
But think in your head.
Oh, I understand.
Taylor had a light bulb. Question asked, do you have an answer?
Oh, I kind of.
Or a thought?
Actually, it's more of an answer.
Okay, let's hear it.
Okay. The one that has a higher molarity is more positive, so the electrons are more attracted to it. Maybe.
Ooh. I'm gonna say my catchphrase.
Right.
Great idea, but no. How was my face though? Any other ideas?
We need to like frame that. Like Mrs. Alviso is like, great idea. Put your thought.
Try again. Evan, what are your thoughts?
So, would, this doesn't really make sense, but would the electrons be going across the thing because the concentration is transferring through the salvage?
Ooh. Getting closer,
But you're wrong.
but still not there. How was my face though for your 10? Zach?
Is it because when the electrons move from the anode gets smaller, so it like dissolves into the liquid, making it more concentrated, and then the other one takes the
Oh, I was wrong.
Yeah, no, I had the same philosophy as Max. So.
Philosophy.
Good. How was my face, Zach? Well done. So what happens, because they want to get to equal ratios, right? That's equilibrium for a concentration cell, right? Same concentration. Well, to get to the same concentration, this needs to get more concentrated. So as the electrons leave, right, it dissolves into the solution, increasing the concentration.
Oh,
And then on the other side, as the electrons come, these attach on, decreasing the concentration until they become equal. Now, the greater the difference between these two, this is where you actually can influence voltage. The bigger the difference in concentration, the more voltage that can be made from the reaction.
So like, if that was like 1 times 10 to the negative a billion,
yes,
it would
yes,
be really high voltage.
Yes.
that would be
Zach.
really.
Is it Ni plus or 2 plus?
Oh, it should have been 2+, thank you.
I feel like to the negative a billion.
I
is
just-
What's the highest molarity someone has gotten to?
Well, because you can
Or like
superheat the
about-
stuff. Remember, like with our salt.
Yeah, that's true. That one would have been a pretty high molarity.
That's probably molarity.
You should have put that in the
I don't know, like at room temperature, what it would be.
Yeah.
I don't know. That's a good question.
You just make a super battery.
Yeah, because eventually you get to a point where at room
Wait, no.
temperature more, you couldn't get it to dissolve anymore, right? Because it reaches saturation.
But once you like heat it, how high can you go?
I don't know. I'll have to calculate what the molarity is of that super saturated solution. So that one's like crazy saturated.
So how
Good
do you
question, I don't know.
with an indicator?
Hey.
Be
Is
red.
equilibrium of 1 or 2 L's? Because you have 2 L's on the top one, there's 1 L on the bottom, and I've always been confused whether it's 1 or 2
I'm pretty
L's.
sure this is how it's spelled. I think I did a double.
Are you sure? I always do 2 L's. Wait, no, do I?
I've
pretty
been
sure
Wait,
doing
I
it.
did the 1 L on the bottom and the 2 L's on the top, dude. I'm like a robot, man.
It's like,
I didn't even notice you. I'm pretty sure it's just one, but
Yeah, I didn't.
Yo, Gabe,
You know what's pretty funny about us thinking
I
that's
don't wanna
HCl
talk
is that if
on
that
the
actually
bottom.
had an indicator in it
What's the?
and it was
it
HCl,
would be that color.
it would look like that.
That's true.
is ACL that
So
like?
now I'm giving you indicator on top of the HCl.
Oh my
Yes.
gosh. Wait, but
It's
is
good for you.
HCL that like
It's open.
opaque though? I thought HCl was like sort of translucent.
Oh, yeah, it'd be more transparent.
It looks
Yeah,
like
we're looking through a frosted or a translucent solid. So it's translucenizing.
It's,
Oh boy.
don't even try and make fake science words with me right now.
Okay,
I like that word, translucent.
No.
so
Stop.
this equation here, everybody, is known as the Nernst equation. It's on, that's a weird LN.
Oh yeah, whenever you draw it, I think it's like a really messed up capital N.
I always think it's like,
That's just me.
I actually think it's like a
LN on your
B. I always
papers.
think it's like a B or an L.
I just do it in English.
Just like LN.
No, I try and copy it, and it always just looks like I grew up. on
I
my
thought
Wait.
LN was IN,
Earth
so like,
nut. Is that like a weird, that's a really weird T.
yeah.
It's an
Wait,
I
is
don't know.
Q the quotient
Oh.
or?
Dude, it's an F. Who would have thought, man? I totally thought that was a T.
This is an F. This is not like me trying to do true or
Our
false.
whole unit.
Wait, that's kind of high.
I mean,
That should be a science thing.
No, I thought
Okay.
like it was.
Now, you know about this equation, everybody. It is on your formula sheet, but the AP curriculum states that you will not be expected to use it mathematically.
Yeah.
So, they give it to you because there will be some, how should I put, theory-based questions
Hey, you'll nail those.
that relate to the equation, but you won't have to plug things in. So let's just talk about what we can learn from it, because that's what I've seen questions be about. Okay, the correlation is this, is that as Q decreases, E will increase. That's what we learned from this equation.
Whoa.
Now E means, so this is where concentration cells come in, because we're not under standard conditions. So let's review really quick. What is Q? Anyone remember?
Oh, it's like not equilibrium, but
Good.
it's still whatever the thing is.
So Q is products over reactants, but not at equilibrium. Now this is once again how you could figure out, like, okay, I want more volts from my battery,
Oh.
so I can change these values. If I want Q to go down,
More, yeah, or less.
good, so we either need more reactants or,
Less product.
What?
Science, Taylor.
In the words of Bill Nye.
Science rules.
so if you want to increase your voltage, you can increase the concentration of your reactants or decrease the concentration of your product to force that equilibrium to flow.
Right. Equilibrium. Force you into something.
Does that make higher voltage?
And then you'll get more volts out of it, yes. So questions I've seen that deal with this is often they'll give you a scenario and they'll say, hey, if I change the concentration to this, would that give me more or less voltage?
Actually pronounced scenario.
Okay. Now, what's important to recognize here, everybody, if the ratio doesn't change, then it wouldn't change at all, right? So you gotta be careful in fluctuating these that you don't keep the same ratio in the end, right? So you kind of really wanna do one or the other, not really both.
It would just make the whole reaction last longer, right?
Good, yes, so we could make it last longer, but you wouldn't actually get a higher voltage out of it, so, very good. Any other questions about this equation? Once again, it is on your formula sheet, but you're never gonna be asked to plug things into it.
Is that all we really have to remember about
It's
it?
E minus Ertner only.
E equals dirt.
So like,
Wait, it's not a T, it's an F.
Dude, you sound like you're speaking some weird like Germanic language. Like for black, that's what it sounds like. Everywhere.
Yeah, I see what you're saying, yeah, there definitely is like a good place to kind of put it in. And maybe you'll see this next equation as we look at, because time does come into play when you start talking about currents. And so, yeah, voltage is related to the current flow, which is related to time. So yes, like there's not a variable to my, it is just volts, right? And I guess the volts are the next thing. Yeah, because you're right, obviously, like when you were to sum it all up, right, you're getting more volts out of the
Like, I still
but
don't even know.
in the
what
process, you're not
that
gonna
is.
be you're like, you know, every single day today.
I know, right?
Yeah.
Dude,
Okay,
that's awesome.
last piece, everybody.
You're along for the ride.
How come I take Isabella's part? I don't think that's fair.
Are you doing AP Physics next year?
Yeah, that's, we were also worried because you're like,
No, Evan saw it and thought that it was actually that. And he was like,
Okay, so last piece of the puzzle is the opposite of a galvanic or voltaic cell, which means you're putting energy into it to make it happen. This is a process known as electrolysis. So electrolysis is the process of sending a current through a system to force things to get reduced and to get oxidized. Pretty much, once again, it's the reverse of what happens when you charge your, well, it is what happens when you're charging your phone. So as the phone runs forward or the battery works, that's classified as the galvanic process. When it's plugged in and you're going it backwards, that's now electrolysis. Now with this process of electrolysis, we have what are known as a way in which you can calculate the current flow to make a process happen, and it's done by this equation, which is on your formula sheet. So I, which is the symbol for current, so you can write this in that little box right there.
You're writing in the thing, the.
Oh, I'm on the sunshine again?
walking on sunshine.
Okay, I'm gonna do it now.
walking on sunshine. Whoa, it don't feel good. Hey! Four.
Hey! Oh, no.
Sunshine.
Lollipops and
No,
rainbows
on my shoulder. Makes me
Okay, come back
happy.
up right here.
Sunshine in my heart.
Is that a Q? Like a lowercase Q?
Wait, is that a 9 or?
Okay.
So we have I is for current, and once again, this is on your formula sheet and all the variables are defined.
Is that like a
Okay.
weird
Q is for charge,
I think that's a
and
weird
then T, lowercase t is for time. We always do capital T for temperature, lowercase t for time. Now, this is on your formula sheet, but it is important to understand this idea of charge. Okay, so the charge of it can be calculated. Okay, so second equation right off in that box too, but just off to the side, is if you figure out how many electrons you have, how many electrons are being transferred, times the mole of your substance, so N, and then times Faraday's constant.
Is that normal moles?
Dude, it's NF.
Nif.
Oh, that's a band, dude. Or I don't, it might just be a single band, I'm not sure.
So then that,
Monty
then we
Python?
use to figure out the charge of the system.
No, I've never seen Monty Python. I know, I need to watch
I got your
it.
marks,
Yeah.
yeah.
Thank you.
So could we label N instead of moles on like in earlier units, could we have labeled N instead of mole for like our ending things?
Yeah. I don't know actually, Isaac. That is a good point, because we always use the letter N, but I don't think it's I don't think you can like put it at like, say I have 0.2 N silver. I've never seen it done.
Okay.
It would make sense to me,
It's quite a
but I've never
daring
seen it done.
trial.
Yeah. Evan,
Would like N equals work?
that would make more sense. Yeah, saying like this equals that. I guess it's kind of the same thing here, right? Where like I is for current, but I is not the unit for current. Current is measured in amps.
But
So kind of same related, but good point. So, okay, any questions on what electrolysis is before I show you one?
oh,
Bless you?
She came back further and used HCl.
Okay, for this, you can turn the camera off. I'll film it later for them because